This video is going to help you to determine the differences between physical and chemical changes. It goes along nice with the previous video we did on physical and chemical properties. Physical changes, basically, are the kind of changes that happen to a substance, but the key is the change will be without any change in composition. Okay, without any change in composition, which means what it's made of, how it's described by a chemical formula, without any change in composition or identity. Now that doesn't mean that it doesn't always look the same when it's done, but there can be a change in appearance. Changes in appearance may happen, but there will be no change in the chemical structure of that substance. And often think about that the change is quite often reversible. It's quite often reversible. So let's narrow down some things that will help you to decide which is which. Some keywords. Some keywords that will help. As you go through these keywords, visualize them in your head and think about the before and after. So cut. Keyword cut. Cut a piece of wood. Cut a piece of paper. Cut a piece of copper in two with a wire cutter. It's not going to be different before and after. The appearance may look different, smaller, but the copper is still copper. Same thing with bend. Okay, you bend a piece of wire. You bend a piece of aluminum foil. Okay, the same before and after. Melt. You take something, a piece of metal like gallium. Okay, gallium is a soft metal. It actually will melt in the palm of your hands in the upper 20s, low 30s degrees Celsius. When you take your hand away from the metal and the heat source is removed, it'll go back and be a solid again. Okay, it's reversible change. The chemistry of the gallium has not changed before and after, so melting is a physical change only. You know, the other one that goes along with melting is boiling. You boil something. If you boil water vapor in a container in which you can capture it and cool it back down, it'll go back to the same water it was before. These are words that are more physical than anything. Crack. Break. You break something in two. Your mother's favorite china vase. Okay, the chemistry hasn't changed. You're going to be in trouble, but the chemistry of the vase is still the same. It's a physical change only. Split. Condense. Okay, that's good for vapors going back to liquids. Crush. All those words are quite physical. Okay, they imply, could very well be a change in the way it looks, but it's not going to be different in its identity. I'm going to give you an example you don't have to think about. It looks so different before and after. But here's a sample of water. Into that water you put sugar. I mentioned when we were doing physical properties. You put sugar, which is C12, H22, we talked about table sugar, O11. Put that into the water. The whiteness, it all disappears. Dissolving, however, is a physical process. Because if you were to evaporate that water off slowly, over time, a period of a week, or if you were to boil it off quickly, at the end, the sugar that's in the bottom of that beaker is going to have all the same properties it did before it went into the water. It's going to be white, it's going to taste sweet, and all the things that go along with being sugar will be exactly the same before and after. So the sugar's undergone a dissolving process. It's a physical change, not chemical. Therefore, in this case, it's easily reversible by getting the water back out of the solution. So changes in temperatures, melting, boiling, dissolving, cutting, all those kinds of things are just physical. As you can probably already predict, chemistry is about chemical changes, we will spend the last half of the course, the entire time, studying just chemical changes. Okay, chemical changes are very different. The word chemical change and chemical reaction are quite often used interchangeably, so you should be prepared to see both. By definition, what it says here is that a chemical change is going to occur when one or more new substances are changed into new substances. You should really get that into your head, that new substances with new properties. Okay, so things are going to get very, very different as a result of a chemical change. Some key words that will indicate this: very, very different than chemical. So rust. You know yourself, if your car is going to rust, that iron is now going to be changed into a new substance, typically an iron oxide, and you can't get it to go back to pure iron. Decay. Something decays, it's changed to a new substance, you can't get it to go back. Decompose. So something decomposes, like a dead body. Decompose is very much, the end result of that reaction is very different than what it started as. Grow. Anything undergoing growth is entirely because of chemical changes inside the body. New proteins, new cell walls, new muscles, new tendons, new whatever. Anything undergoing growth screams chemical. Digestion. Okay, think about hamburger in, hamburger out. Okay, the end results are very different than what went in. Maybe not corn, but everything else goes in and out. Very, very different. There's been an absolutely change in the chemistry of the substances with new properties. Corrode. That word we mentioned before, we were talking about chemical properties. Well, you cannot test if a substance will corrode without actually allowing it to corrode. So corrosion, if something does corrode, it's undergone a chemical change. Rot. Okay, think about like in your fridge, an old rotten something in the back of the vegetable drawer. It's disgusting. Ferment. So fermentation can be a nice process if you're trying to turn sugar into wine, right? Some sugar into alcohol. That can be a beneficial thing. Burning. Anything that's going to burn before and after are very, very different. These words should all scream at you new substances at the end. Okay, I'm going to give you an example of a chemical change that we've all witnessed, we've all partaken in no matter what. This is an example of what happens in your barbecue. So C3H8. I would expect you to look at that based on your limited chemical experience so far and know that that's a compound. Specifically, it's propane. Okay, now it says liquid. I'm gonna change that. I wrote it down not ideally. Propane goes into the tank as a liquid. Well, actually it goes in as a gas. It comes back out after it's uncompressed as a gas. So propane, when it reacts and burns, you need oxygen. O2 is a gas. I wrote it as a 2 subscript because oxygen is one of those special elements that's unstable by itself. It needs to be in a pair. It's called a diatomic element. When these two substances react, if they are exposed to a flame, then they will burn. When they burn, what you get is carbon dioxide gas, CO2 as a gas. You get water, but the water does not drip down to your feet, and you don't need to wear rubber boots. Okay, the water is in the form of steam. And you get a third thing that you don't think about, but it's the whole reason why you're cooking with propane in the first place, is you get heat. That heat is not, it's energy, it's not matter, but it's still part of the overall reaction. So if you look at what you started with, propane and oxygen, what you're getting are new substances. So therefore, it must be a chemical reaction. If you're producing new substances, ding, 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 that's a chemical change. I want you to note, however, that all of the elements are still exactly the same. You started off with carbon and hydrogen together, oxygen separate, bunch of collisions happening, there's flames, the spark, and you have rearranging of the bonds, and now you get carbon with oxygen, hydrogen with oxygen, and you also get heat. This is propane fuel, and you're going to get new substances on the right-hand side. So when you want to ask yourself if a chemical change has happened, you have to ask yourself a question. And that question is, has the substance changed its composition? If it has, then it's chemical. If it didn't, then it's physical. There are certain indicators of chemical changes that'll help you to answer that question very easily most of the time. This is absolutely test-worthy, and it'll always come up in every single thing we apply it to. Indicators of a chemical change. It's quite simple, quite straightforward. The first one is if you detect a new smell that wasn't there in the first place. So if you're anything like my mother, you go into the fridge, you start sniffing. Sniff the meat. Does the meat smell rotten? If it smells off, it's probably undergone a chemical change. It's probably starting to decompose. If you can detect a new smell that wasn't there in the first place, there's been a chemical change. If you can detect a new color, so you had a solution that was clear, and all of a sudden it turned blue, then you would know, oh, something chemicals happened because there's been a change in the color. A new color was formed. If all of a sudden, putting two things together, you can see heat and or light that wasn't there in the first place, then that's probably going to be an indication that there was a chemical change. Heat or light observed, and that's of course forms of energy. If you did not have bubbles, but now you see bubbles inside your beaker, bubbles tend to indicate the production of a gas. And if there was no gas in the first place, then you know you have a new substance being formed, which should tell you that it's a chemical change. If you have what's called the production of a precipitate, which means basically if you put together two liquids and all of a sudden there's a solid mass that appears in the bottom of your container, probably even a different color, and it settles to the bottom, makes a heterogeneous mixture, then that would tell you that there's very likely been a chemical change, because you went from having two solutions to the production of a solid, and that is a very important indication of a chemical change. A precipitate is basically a solid that's formed from a reaction of two solutions. Okay, and we'll study that in a ridiculous amount of detail later on. But that key word is a precipitate. And lastly, how do you know you've got a chemical change going on? Quite often, if the reaction is not easily reversible, unlike being able to get the salt back out of a saltwater solution, or the sugar back out of the sugar water solution, or taking your liquid and turning it back into a solid, or taking your vapor back into a liquid, or any one of those, if it's not easily reversible, there's a very good chance that it is a chemical change. This diagram comes in your book as well. 3 different pictures. The one on the left, which is probably clear in your picture, is indicating a piece of solid metal. This could be zinc, it could be aluminum, it could be anything, magnesium, a metal like that that's put into an acid. And what you should see in the picture is that there are bubbles being formed. And those bubbles are an indication of a gas that wasn't there in the first place, and therefore it's an indication of a chemical change. The second beaker is a similar idea, but it's a much more reactive metal, so say potassium. If you put potassium metal into a beaker containing water even, it will, not only will it react and produce a gas like hydrogen, but the hydrogen gas that's formed above that beaker will actually light up and explode. It's a very vigorous reaction. The far side shows exactly that concept I mentioned about a precipitate. If you form two, or put together, two liquids that are classified as homogeneous mixtures, solutions, nothing in them, and all of a sudden you see a solid formed that wasn't there in the first place, and it settles to the bottom of the beaker, that's called a precipitate. These three beakers are all indicators of a chemical change. These 4 examples I want you to try, pause the video and come back. Are they physical changes or chemical changes? They're the same ones I presented at the end of the last video, but we couldn't really answer. Part A, touching a candle that's lit to a hydrogen bubble gives an explosion. So an explosion would imply that we're talking about a change in the chemistry, right? That's going to be a big kaboomer, and that would be a chemical change. You're not going to have explosions with chemical changes. Heating water in a flask produces moisture on the glass. That would be water turning from a liquid to a vapor. That's a change that's reversible. That's boiling, that's a physical change. Combining 2 colorless solutions to give a yellow solid, that's that new word we learned, precipitate, which is a chemical change. And D, vinegar on baking soda. You've all probably done that in your own kitchen. Maybe you've used it to clean some pipes in your sink, toilet, whatnot. If you mix together vinegar and baking soda, you will get the production of a gas that wasn't there in the first place, and that's an indication of a chemical change. Another exercise from the Corwin textbook, the one you have with the other one. Physical change or chemical change again. Freezing water in a refrigerator makes ice cubes. That's water going from liquid to solid. That's a change in state. That's reversible. Therefore, it's a physical change only. Adding silver nitrate to tap water to form a cloudy solution. We don't know what the hell silver nitrate is yet, but you do know when you add 2 things together and you get something cloudy, it's no longer a solution, from homogeneous to heterogeneous, there's a very good chance that it's a chemical change because you produced a new state. You get bubbles or solids that weren't there, chemical change. Burning, ding, 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 burning. Burning is always going to indicate chemical change. Burning sulfur gives a light blue flame. Okay, anything that burns is going to be chemical. You're not going to easily get it back, probably not at all. Therefore, it's gone. D. Grinding aspirin into a powder. That's just a change in the way it looks. But you have not changed the chemistry. It's aspirin before and aspirin after. It's just gone from a convenient tablet into a powder. That's only a physical change. Okay, here you will see 3 statements about charcoal. Charcoal is a black solid. Charcoal turned to a gray ash when it burned in air, and charcoal will burn. If your choices are physical property, chemical property, physical change, chemical change, I'd like you to stop the video for a second and to classify each of these 3 things by one of those terms. Charcoal is a black solid. Charcoal is a black solid. You're describing the color only. The chemistry hasn't changed. And that then would be an example of a physical property. Turned into a gray ash when it burned in air. That implied a change because it changed in color. It turned. And there was an indication clearly of from black to gray. Burning. Those are all indicators of a chemical change. Not reversible. And will burn. So will burn is an example of if you light it up, it's going to change. But I didn't say that you did burn it, just that it will burn. That's an example of a chemical property. The fact that it will burn will tell you that it will make a new substance, but it hasn't burned. So it's a property, not a change. Here are a few more examples of some questions where your job is to identify if it's a physical property, chemical property, physical change, or a chemical change. So let's start with the first one. Take a second and pause if you want to do it on your own first. Alcohol is flammable. So flammable would mean that you'd light it up. If you lit it up and you tested if it was flammable, then it would change from alcohol to carbon dioxide and water probably. The fact that it is flammable is a property, and the fact that it would make a new substance if it burned would be chemical and not physical. So flammability is a chemical property. Alcohol is volatile, meaning it evaporates rapidly. Evaporation is a process where it changes from a liquid to a gas. That's a physical change in state. It says it is volatile, it will evaporate easily. Those are both physical properties. A sample of table salt dissolved in a glass of water. So you put some salt in water and it dissolved. That implies a change. Is a change chemical or is it physical? You can get the salt back if you evaporate the water. That's a physical change. Over time, a flashlight battery lost its charge. Well, a battery loses its charge because the chemical reaction stops because you ran out of fuel in the battery. One of the reactants got used up and you ran out of stuff. So if it's decharging the whole time, that's a chemical change. You cannot get it back unless it's a rechargeable battery. Then you can apply electricity and get it to come back. So let's talk about the questions in your booklet that you are going to do for practice. So I'm going to put these, I'm going to get you to stop and do these on your own, and then come back and we'll check the answers. In your booklet, you'll find these questions under your picture for chemical changes. Which of the following are physical properties and which are chemical properties? Physical versus chemical. So physical means nothing changes in the chemistry. Chemical means you'll make a new substance. Because if you test, for example, if it'll burn, you're going to lose it. It melts at 1284 for copper. That's a physical property. If you melt it, it's still copper, just in a liquid state. Measure its density. You figure out its mass per volume. That's also a physical property. Okay, if you measure that, you're not changing the copper. If it conducts heat, copper gets hot, copper gets cold. The copper is still copper. All those are physical properties. D, however, says copper turns green when exposed to chlorine. If there's a change in color, that indicates there's a change to the identity of the substance. It's changed from something to something else. Therefore, it is going to be, that would be a chemical property. If it turns green, if it will turn green when it's exposed. So when you expose it, that's like a fact. chemical property. Physical change or chemical change? Copper metal strip will bend without breaking. Bendability is physical. Doesn't change the copper, it's still copper before and after. After being heated, the copper metal strip is brittle and breaks when it's bent. Again, it's still copper before and after. You've changed the arrangement of the bonds maybe, but not the identity. Copper is copper. Zinc metal melts when heated to 1420. Melting is physical. Physical change. Hydrogen gas bubbles are released when zinc metal goes into acid. If you all of a sudden see bubbles, bubbles are an indication of a chemical change. Lighter fluid evaporates when spilled on the floor. Evaporation is liquid to a gas. That's a physical process only. That's a physical change. Alcohol burns. Burns is a key word. If you burn it, you're not going to get it back. It's gone. That's a chemical change. Candle wax becomes liquid when heated. Solid to a liquid. That is only a physical change. Candle wax burns with a yellow flame, yellow-white flame. Burning is by far and always will be a chemical change. Burning. That's a little summary of physical and chemical changes. Previous video, physical and chemical properties. Combine those together, you're going to have 3 million questions that you can answer about these concepts. Enjoy.